थांब 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 गो लाईव्ह करू. आता दिसतंय? हॅलो हॅलो. आता आलं? ओके. हम्म. ओके ओके. हाय. Sorry for the delay in the time and everything. I think there was a setting issue or okay. Can you hear me? Please hit please hit like if you can hear me, or just let me know you can hear me, because this is my very first live and I'm not conversant with the settings of all this software which I'm using. So I'm just trying to gauge the whole thing properly, and I'll again explain, because there was a glitch entire thing. Please hit like or just let me know if I'm audible in the comment section if you are there. Okay, thank you so much. Now I'll explain again the whole thing, because it was overlaid on the whole part. I was not aware that I was not able to go live. I thought I was live and I was just streaming over there. Okay. uh, I'll explain the whole thing again. See, we are discussing over here with the eigenvalues and the eigenvector. So in this topic there are few important things are there, basic theory you need to know for this. After that we will be seeing how to find eigenvalue and eigenvector. Then there is diagonalization of the matrix. Then there is this similarity of matrix that we can see, or similar matrices. And then there is going to be Cayley Hamilton theorem. Now these are the few important things that are there, that will be all throughout. Now there is this very basic theory which I have written down here, that is, let A n cross n be a square matrix with real entries, alright, and then A n cross n x n cross n equals to lambda x n cross 1. This is the fundamental line that you need to remember, and the most important thing in this capital X should not be equal to 0. Okay, This is the most important thing. For some time I'll just close my camera. Yeah, you can see here. MU third semester, MU fourth semester. This topic is there for some students in third semester. This topic is also there for somebody in fourth semester. It is there for most of the MSc students of mathematics and physics, as well as it is there for the students of all other university. It is also taught in BSc level. Okay, so this is there. Those of you have done in semester 3, very good. Those of you have done in semester 4 right now, if you are doing, that is also there. It is there in almost every university. This topic has to be covered if you want to go for advanced courses, because this is the entry point into the advanced course. A very good morning to Ayush Sahu. Yeah, so this is the topic which is across all the branches. It has to be taught, because after this opens the gate to enter into the machine learning, principal component analysis, linear discriminant, and many other statistical and mathematical concepts, because this is the fundamental concept. Even if you are doing a course on linear algebra, you will encounter eigenvalue, eigenvector. If you do something related to oh, what we can call differential equations or system of differential equations, then this is the topic that you will come across. So let us see how to handle this one. So the basic theory over here is, let A n cross n be a square matrix. If you have written down or taken a snapshot of this, then it would be very good. Please do take down this theory, because without this you won't be able to go ahead. These are the terminologies which we'll be using very often, and all throughout we will be using them. Okay, so am I clear to you on this part? So what is the basic theory that we will have here is A n cross n into capital X n cross 1 is equals to lambda x, such that capital X is not equal to 0. Okay, and lambda is a scalar. Lambda can be a complex number, it can be real number. We have no problem with lambda. And then a little bit of mathematics gives us determinant A minus lambda I equal to 0. On solving, we get this polynomial. This equation number 2, when you solve it, doesn't look like a polynomial, but it is a polynomial. So on solving, we get a polynomial equation in lambda, and the roots of this polynomial, I would say here it is the roots. Okay, the roots of equation 2 are called eigenvalues or eigenvectors. Sorry, they are called eigenvalues, and they are also given the name characteristic roots, latent roots, etc. Okay, these are the three names you get over there. Now from equation 2, when you get eigenvalues, equation 2 is called characteristic equation. Please hit like if you have understood these two concepts. What is characteristic equation and what is eigenvalues? Okay, please hit like, or just let me know that you have followed. From equation 2 you get some values, those values are eigenvalues. And what is equation 2 called? It is called characteristic equation. These are the two fundamental things you will need to know. Now remember this equation number 1 all throughout. This is going to be useful all throughout, because that is the base statement on which the entire concept is made. Please let me know whether you have followed this or not. So just hit like, or let me know how it is going with you. Okay, so we see there are few people who are there. I believe you are busy writing the notes. Let's see. Now, after this comes how to find eigenvector. See, from equation 2, that is determinant A minus lambda I. Okay, we have Yash and Akash saying this, they have followed. Okay, now you can take a snap of this or you can write down this. From equation 2, we have determinant A minus lambda I equal to 0. Okay, that is the main equation, which is called characteristic equation. That equation, when we solve, we get eigenvalues. Now how many eigenvalues we will get? We will get that many eigenvalues whatever is the order of the matrix. So if matrix A is of order 2, we must get 2 eigenvalues. Either they are real or they are complex. Okay, so lambda 1, lambda 2, lambda n. Then for each lambda I, we solve the system A minus lambda I times x equals to 0 to obtain its corresponding eigenvector xi. Alright, so this is what we get here. So now see, this is pure mathematical theory, theoretical way of giving the whole thing in short. So we will see details regarding it with an example. But before that also we need two most important formulas which are there, and they will be very useful throughout. So the first formula I give you over here. Now I'll just put on my camera so that you people can see me and I can be, just on screen. Okay, so here you can see me. Okay, now let's go to the most important formulas here. These are the two most important formulas. That is, if A is a 2 cross 2 matrix, its characteristic equation is given by this formula: lambda square minus trace of A times lambda plus determinant of A equals to 0. This is how it is there. Now if A is a 3 cross 3 matrix, then its characteristic equation is given by this white formula, which is written a bit longer here: lambda cube minus trace A lambda square plus m11 plus m22 plus m33 lambda minus determinant of A equals to 0. Now what is m11, m22, m33? M11, it is the determinant of the matrix obtained by deleting the ith row and the ith column. We will see all this thing in detail. First we will need these formulas all throughout. You can take a snapshot of the screen if you like it, or please write down, because these are the two formulas you will be using very frequently and you have to get used to them. You will get used to them as you practice more and more questions regarding the eigenvalues, but for time being we will be seeing them here. Now I would like to tell you one very important thing here. Many places the notations they use are S1 and S2 and S3. I would request you to avoid them, unless rather make them very specific. The S1, S2, S3 is a very general way of like the examiner or the person who is correcting may not be aware what is S1, because you are just calculating and giving them S1, S2. When you write M1, M2, M3, you come to know what it is. Okay, yeah, M11, M2 to M33, you will be, you know, it gives a clear picture to the examiner or to the person who reads it, that the person is knowing regarding the more technical mathematical notations. Okay, so let us go further. You take down this thing, and if you are done with this, we will go ahead and take up a problem how to solve the thing. Okay, so let us see how to go about it. You can ask other people to pour in, because I was in a glitch. I thought it is working, and I was not aware that it was not being live streamed in between. I thought it was going live, and I was, under another impression. So yeah, okay. So now let us go further for the example now. We take up this very small example, a 2 cross 2 example, to understand how the things work. Later on we will see a 3 cross 3. Just after this example we will see a 3 cross 3 thing. Now please remember that any question in the eigenvalue eigenvector topic can be given many multiple questions. Okay, it is not that just find eigenvalue eigenvector, they can add multiple layers of question to it. So we will see how to handle first layer. The first layer is a very standard question: find the eigenvalue, find the eigenvector for the given matrix. So let us see how to go about it. Anytime you have this kind of a question, any time in the examination or any corner of the earth you are, कहीं पर भी हो, सबसे पहले यही line लिखनी है. This is the first line you are supposed to write in the question of eigenvalue eigenvector. That is, let ax equal to lambda x, x not equal to 0. This is the first line that has to be in your answer. Otherwise it's going to create problem. Now the next line that you must write is this: determinant a minus lambda I equal to 0. This is what is required. Okay, this is a fixed step. These two yellow lines that I am writing, in any question whenever they ask you to find eigenvalue eigenvector, these two are the fixed steps that you are supposed to write. Now the next step is here. We now take determinant. Now see what is to be done. From the matrix you write this notation det. Okay, because many of you make mistake while putting that vertical bars, so I'm giving you this notation det. So when you write this, what you do is, here from the matrix you subtract the, from the diagonal elements of the matrix you subtract lambda. So 1 minus lambda, 3 minus lambda, and then there is this 4, and then there is this 2, which is equal to 0. Okay, so this is what you get. Now you use the formula which you have just written down. The formula for finding the characteristic equation is going to be lambda square minus the trace of a times lambda plus the determinant of a. This can save you from losing marks. So you write down the formula, you may get some marks that time. So what is lambda square minus trace A. Trace A means the total of the diagonal elements. Trace A का मतलब है डायगोनल एलिमेंट्स का टोटल. सो 1 और 3 डायगोनल मतलब कौन सा डायगोनल, हमेशा मेन डायगोनल ही लेंगे. Okay, so diagonal means this. Okay, these are the diagonal elements over here. 1 and 3, you can see them, I have highlighted. So 1 and 3 are the diagonal elements, so you add them up. So your total becomes 4. Okay, so you get 4 lambda. Now the determinant over here is going to be, so the determinant is, yeah, 3 minus of 8. Okay, so it is 3 minus 8 is the determinant, equals to 0. So you have lambda square minus 4 lambda minus of 5 equals to 0. You can solve this quadratic equation in your calculator, or you know the solving technique, then you can do it. So here you get lambda minus 5, lambda plus 1 as the factors. So lambda equal to 5 and lambda equal to minus 1. These are the two values that you get, and these two are the eigenvalues of your matrix. Okay, now see, I told you you will be getting characteristic equation, right? So your characteristic equation is this. I'll write here, is the characteristic equation. And these are the eigenvalues. Okay, please hit like if you have understood. Yeah, thank you, very informative. Thank you for that. uh, Please let me know if you have understood this part. Just hit like or say yes, I would go ahead after this. These are the fundamental things that you need to know. So we have Shraddha Gosavi over here, so she is saying very informative, thank you. Yash is saying done. Okay, so are there any other people who are there? Yeah, Tanishka says yes, Akash is saying right. Okay, so fine. I believe we are done over here, and now we will go for the next portion over here. So the most important thing now comes is that we have to find the eigenvector for each of the eigenvalue. Now we used this theory that we had written. In theory, we just saw that whenever we find the eigenvalue, so what we do over here, first thing is we'll label them. So let lambda 1 equal to 5, and we'll label lambda 2 equal to minus 1. We can label like this as our convenience. After this, what we do is we write for finding eigenvector. Okay, this is the heading we give, and then we start finding the eigenvectors. So for lambda 1 equal to 5, what are we supposed to do? We first write a minus lambda 1 I times x equal to 0. This is what we write. So what do we do here? A minus lambda 1 I times capital X equals to 0. So this will be how we do now. So you substitute a minus phi I times capital X equal to 0. What does this a minus phi I give us? So let us see what to do. from the matrix that is given to us 1 2 4 3, what you do, from the diagonal elements you subtract 5. So the moment I subtract 5 from the diagonal element, from 1 I'll get 1 minus 5 is minus of 4, and from 3 I will get 3 minus 5 is minus 2. So I get here the remaining elements as it is, as the way they are. Okay, don't touch the other elements, only the diagonal elements are to be touched. Followed this much? Yeah, I hope you have, or you are able to keep a track of this. Now capital X, when you have capital X over here, what is capital X? Capital X is a vector which is going to be like this in terms x1 x2. If you have a 3 cross 3 matrix, it will take x1 x2 x3. If you have a 2 cross 2 matrix, it will take x1 and x2 as the column vector. I hope you understood this concept. Now see, this is what is the system of equation that we are supposed to solve. Okay, so yeah, now we solve this system of equation. How do we solve this system? Let us see first. We can see that the first equation, okay, when we see the first equation, it is just the matrix. We can divide the entire row by 4. So we divide r r1 r1 changing to r1 divided by 4, and r2 can be divided by 2, r2 changing to r2 divided by 2. So what do we get is, see here, we will get minus 1 1, and here we get 1 minus 1. You don't touch the vector x1 x2, okay, you just keep that elements the way they are. And on the right hand side you will always have 0 0. Okay, now what we do here, minus 1 1 1 minus 1 we have. Now see, when we simplify this further, what we can do is, essentially the first row is negative of the second one. So what we can do here is, we will now do r2 changing to r2 plus r1. When we do this, we'll get minus 1 1 0 0. This is what we get, x1 x2, and this is 0 0. Okay, this is what we get. Now there is minus of x1. Now perform the multiplication. There is minus x1 plus x2. आपको ऐसे करना है. इसके बाद आपको क्या मिलेगा? You will get minus of x1 equals to minus of x2. So here you get x1 is equals to x2. This is the first relation you have got. Now we go for writing the eigenvector. When we go for writing the eigenvector, let us see how it is done. Capital X is equals to, of the format x1 x2. Now we have already told that x1 is equal to x2. So what you do over here, try to understand this carefully, that instead of x1 I am going to write x2, and for x2 I will not write anything, because I know if I write again x1 equal x2 equals to x1, then I will land up in the same previous situation. So what we do, x2 is equals to x2 we write, and then x2 we take it common. Treat x2 as a scalar. Treat it as a scalar and take it outside. So this 1 and 1 remains inside the bracket. Okay, so this is what we get, that x2 is outside and 1 1 remain inside the vector over there. So now we put x2 equal to 1. You can put any number of your choice. You can put 2000, 5000, 1500, but do not put x2 0. x2 cannot take value 0. This is very important. Remember here, I'll just say here a very important thing. You can put any value for x2, but x2 is not equal to 0. Yeah, remember that. You cannot put here 0, because we have written down very important thing in the beginning. What is that? Capital X is a non-zero vector. So when you are writing here that capital X is non-zero vector, you have to remember that x2 cannot take 0 value. So now when we go for solving, here we get, now see, this is a general vector. Now when we have put a specific value, we will now write x1 is equal to 1 1. This is my first eigenvector, so I just write here is the eigenvector for lambda 1 equal to 5. This is the eigenvector for lambda 1 equal to 5. If you have understood this, please hit like, and we will see how to go further. Just hit like, or let me know your output, what have you understood out of this, and then we will proceed further. Okay, so those who are following this, let me know, and then we will go ahead in this. Now what we do here, we have found the eigenvector for lambda 1 equal to 5. So now we go for finding the eigenvector. So we'll take here, we go for now for lambda 2. Lambda 2 is minus 1. Okay, what do we do here? Formula is a minus lambda 2I bracket x is equals to 0. This is the formula. Now what you see is, in the diagonal element, what will happen here, you substitute lambda 2. So the moment you put lambda 2 is minus 1, so it gives you a plus I. Okay, a plus I times x equals to 0. Now what does this mean? It means in the diagonal elements you have to add 1. Okay, in the diagonal element you add 1. So what will happen here? The matrix that we had was, in the diagonal element there is 1 and 3, right? So 1 plus 1 is going to be 2, and in the other here it is 3 plus 1, that is 4. Other elements are as it is, as the way they are, do not change them. X, here there is 2. Okay, so here there is 2. So all other elements the way they are. and 0 0. So this is what is going to happen. Okay, fine, you understood. um, Now see, this is very important that when you get an eigenvalue lambda 2 equal to -1, you have done this change. See, when there is eigenvalue is positive, you have to subtract, but when the eigenvalue is negative, you have to add to the diagonal element. Okay, you add that eigenvalue to the diagonal element. So here you perform this, you get this this is as the matrix. Now we see what is going to happen. 2 4 2 4, the both the rows are same. So after that, you can, if you want, you can write this step. This is a it is technically important, I'll tell you why, but you will realize the importance later. But right now we write down r2 changing to r2 minus r1. So what happens here is 2 4 0 0, and here there is x1 x2, and then there is 0 0. Okay, now what do we have here is, when we get the equation here, the equation is going to be 2x1 plus 4x2 equal to 0. ये इक्वेशन आपको मिलता है. ये इक्वेशन मिलने पे, when you get this equation, what is the output that we will get? Let us see. The output over here is x1 minus 4x2 divided by 2. So therefore x1 is minus of 2x2. Right? This is the equation or the relation I get over here. Now I try to write capital X. When I write capital X as the general formula or the general format, it has x1 x2 as a standard column vector. What it becomes now? Minus of 2x2, and here it is x2. You can see that my vector has got only one scalar. The scalar is x2. Treat x2 as a scalar. You bring that x2 outside. The moment you bring that x2 outside, inside what is left is -2 and 1. And now you put small x2 equal to 1, then you get your capital X2 as the eigenvector, which is -2 1. These are the two eigenvectors that we get. So here we now write down that is the eigenvector for lambda 2 equal to -1. Okay, is the eigenvector for lambda 2 equal to -1. So what all things we got here? The first is the eigenvector. So I'll just make a note here. The first note is lambda 1 we got 5. So for that eigenvector we had got eigenvector 1 1. Lambda 2 we got as -1. We got eigenvector x2 as -2 1. Alright, so now here these are the two eigenvectors. Now there is one very important thing to understand regarding them. Please try to note this, and these are the famous properties rather. So the first thing I would like to tell you here, let's say this is the property here, that trace of the matrix we had seen the trace of the matrix is 1 plus 3, which is 4, right? But trace of the matrix is, when the matrix is given, it is the total of the diagonal elements, right? That is one definition. But in terms of eigenvalue, uh, in terms of eigenvalues, trace of the matrix is the total of the eigenvalue. So lambda 1 plus lambda 2, if you do, you will get 5 minus 1, which is 4, which is also the trace. Okay, so remember that trace of any matrix is the total of its eigenvalues. Okay, the third thing is determinant of A. We can calculate the determinant from the matrix, but if we know the eigenvalues also, the determinant can be calculated. Determinant is the product of the eigenvalues. So here this is 5 times minus 1, so minus of 5 is the answer. Alright, so I hope you have got this. Yeah, this was for some students this was in semester 3. It is, for some students it is there in semester 4. Okay, so I am doing this again for those who are there, and everybody is going to benefit all across the globe, because this topic is very, very popular amongst all the people, those who want to do machine learning, artificial intelligence, linear algebra, or coding, or anything like that. This is all across, everywhere this is going to be useful. So this is in short what the matrix has given us in understanding. Now let me take you to a concept which leads you to a generalization or much further detail. We will see here. So let us first write the same formulas in detail. So I'll give you this as two most important properties. You can write down them. These are the properties of eigenvalues. Properties of eigenvalue, as we just saw. If A is n cross n matrix and lambda 1, lambda 2, lambda 3, so on up to lambda n are its eigenvalues, then we just saw the two most important property, that is trace of A is the total of all eigenvalues. So that would give me, now see, this is total of all eigenvalues of A, to be more specific. But if I write mathematical way, if I write the mathematical style, then you might feel little bit intimidated. But then this is the notation, lambda k going from 1 to n. This is how it is written. So it is the total of all eigenvalue. Now this notation you may not have seen, but then let me give you. Determinant of A is the product of all eigenvalues of A. Alright, so product of all eigenvalues of A, how it is denoted mathematically. Generally, see, most of the people get restricted to the syllabus and the kind of notations are being used, but now this is a free platform, so we can just freely use the notations. So I'll give you the technical notation. Whenever, see, product, when you multiply two numbers, there is not a big thing. Four numbers, not a big thing. But when you have to multiply 400 500 numbers or four symbol, the notation style, the product notation is pi, capital pi. Okay, pi of lambda k, lambda k you can write. So k going from 1 to n. Product, this is the notation. Okay, lambda k. So this is how it is written. So don't get scared from the notation. You can remember the English version, and the mathematical notation is determinant a. This is the formula kind of thing, just to looks little bit fancy. Now let me give you one very important result with this. Okay, I'll give you a very important result over here. You don't even need to go to what all things are there regarding diagonalization and all. You just, sometimes in exam they ask you this question, that whether the matrix is diagonalizable and or not. So we will see that a very important result is this. So the result is, if all the eigenvalues of matrix A n cross n are distinct, then the matrix capital A is diagonalizable. Diagonalizable. Now this immediately brings me to a very new and a very important concept over here, that what is diagonalizable matrix, right? So let us see over here. If we just write what is meant by diagonalizable matrix, I'll just write here heading here. Okay, diagonalizable matrix. Now see, I am giving you this as a very basic version. I will deal with this same concept in detail with more technical what do you call, technical mathematical thing in the next live session. Right now, for the first live session and to digest with a very easy problem, I am taking up over here this way. Otherwise you can do the more technical way also. Diagonalizable matrix. Okay, so if let's say, let A be an n cross n matrix. Okay, if there exists a non-singular matrix P n cross n such that A is equal to PDP inverse such that A is equals to PDP inverse, where D is a diagonal matrix, then A is said to be diagonalizable. Diagonalizable, this is the language that is used. Okay, so D is a diagonal matrix, and that is what they say. Now I would like to tell you very important thing here. You can just continue along with this whole thing. The very important thing here is that how is D made? D will be made up here. You can write as a note. The first note will be here D equal to lambda 1, lambda 2, so on up to lambda n. Okay, on the diagonal entries, rest other places there is 0, so n cross n, this is how it is. And P is a matrix which is made from the eigenvectors, so x1, x2 up to xn. This is how it is made. So the columns of P would be the eigenvectors, and the diagonal of D would be the eigenvalues corresponding to the eigenvectors. Okay, now let us see how all this thing is there. And there is something more here, that P is called the it is, I'll just erase, P is called transforming matrix, or it is also called modal matrix. Okay, if you have any doubt over here, please let me know. I will you know change the whole thing if you have any difficulty in this. Yeah, okay, some people are there, some are not there, so let's see how to handle about this. Now P is called a transforming matrix, P is a modal matrix, or that way. Now the same question we can take up. Let us see. We have found the matrix over here. So see this, in the exam you can get this question, a very simple question: diagonalize diagonal diagonalize the matrix A equal to 1 2 4 3, right? So what all things are to be done over here? Step number 1. Step 1, find its eigenvalues and eigenvectors, which we just did. So we found that, so here we have found the eigenvalues, right? So we have found them here as lambda 1 is 5, and we have found x1 for it as 1 1, and lambda 2 we found as -1, and capital X2 is -2 1. We have found this. Okay, after finding this eigenvectors, what we are supposed to do, we now formulate a matrix capital P. So step number 2 will be make capital P and D. Okay, we have to make this matrix, these two matrices we make them. And so what is P? P is made up of the eigenvector x1 and x2. These are the two eigenvectors we have here. So here they are 1 1 and -2 1. Okay, and matrix D is going to be made from lambdas, lambda 1, lambda 2. So lambda 1 is over here is phi minus 1 0 0. So here these are the two matrices. Now we have to show that the matrix is diagonalizable, right? Now here whenever like this is asked, you have to do this, right? Consider we have to show this thing PDP inverse equals to A. This is what we have to show. So we here write down that consider PDP inverse. So we first write down consider PDP inverse, and then we write down the matrices 1 1, and the eigenvalue eigenvector here is 2 minus 2 1. Matrix is here we have phi minus 1, okay, phi minus 1 here 0 0, and then here you have the inverse. Now how do we find the inverse of a 2 cross 2 matrix? Let us see. So for a 2 cross 2 you can write down directly from your this what you call the calculator, okay. So when we are calculating the inverse of 1 minus 1 2 and all, so what you need to do is you just swap the diagonal entries, 1 and 1 swap, they will give you 1 1 again, and you will have the negative sign on the off diagonal entry. So change the sign to negative. So minus 2 will become 2, and this minus 1 will become minus 1. So this is what you get, and you divide the matrix by the determinant. So determinant of this matrix we had already got was minus 5, right? So you divide it by minus no the determinant of this matrix we will have to take. So the determinant of this matrix is not minus 5, sorry, it is going to be 1 minus minus 2 is 3, okay. So it is by 3, so here you divide by 3. So you get here 3 and here by 3. So this is the matrix. Now when you multiply this in your calculator, you will get the matrix A back. So here you must get A back. So let us see how to do that. Minus 1 into 5 and minus 2, so this is going to be 5. This one is going to be 2, okay. Here you go do the answer. Here you will get 1 into 5 is 5, and here it is minus 1. You do this multiplication now. 1 by 3 minus 1 by 3, 2 by 3, 1 by 3. When you perform this multiplication, you will get 5 by 3 minus 2 by 3, and then here you will get 10 by 3 plus 2 by 3. Then there is 5 by 3, and then there is plus 1 by 3. Here you will get is 10 by 3 and minus 1 by 3. Alright, so this matrix, when you simplify, you get 3 over 3, that is 1, and here you will get 10 plus 2 is 12, 12 by 3 is 4, and here you get 2, and here you get 3. This is the output of A. So therefore you say that matrix A is diagonalizable, diagonalizable, and that's what is there. And what we had also seen, we have seen this result. If all eigenvalues of matrix A are distinct, then you say that matrix A is diagonalizable, and you find the diagonal form of the matrix A. So diagonalize the matrix A, so it means this is matrix A is diagonalizable, and this thing is the diagonal form of the matrix A. So that's what is to be done when you get this kind of a question. I hope you have followed this. Please hit like if you have followed this concept, and then we go for the next concept. Now we take up a very crucial example for finding eigenvalues of a 3 cross 3 matrix. Okay, so this is an example for finding a 3 cross 3 matrix. Let us see how to do that. So let us take up the example. Question number 2 here we'll take is this: find the eigenvalues and eigenvectors for. We'll take the eigenvalues and eigenvectors for matrix A equal to 8, 4, 3, minus 8, minus 3, minus 4, minus 2, and 1. We do this. Now what do we do here, and how do we get that whole process done? Now let us see. Here we will be seeing how to use the formula of a 3 cross 3 matrix when we had this 3 cross 3 matrix, and how to handle with the characteristic equation. So let us see how to do this. So first step, we write that standard step. The standard step over here is, let Ax equal to lambda x, x not equal to 0, determinant A minus lambda I equals to 0. This is the most standard step. Okay, you have to write this all the examples, all the questions, whenever eigenvalue eigenvector step they are asking, you must write this step, because this will keep you tied up to the concept that eigenvector is not equal to 0. Because I have seen several answer sheets and several students who land up saying eigenvector is 0. Eigenvector by default, by its definition, is a non-zero vector, so we cannot write it at 0. So this is why this thing should come very beginning. This is the root of the problem. Okay, so please address it correctly, then you will be able to get it done. Okay, so now like if you are there, let me know. We will see how to handle this thing in detail now. So if you have any difficulty, let me know. I'll just try to address it if there is it's just going little faster or little slower the way it is. So let's do now. We now write determinant, write the matrix here. You can write matrix A minus, what you need to do is this: from the diagonal elements 8, minus 3 and 1, you subtract lambda. So 8 minus lambda, minus 3 minus lambda, 1 minus lambda, minus 8 minus 2 minus 2, 4, 3 minus 4 equal to 0. Now you write the characteristic equation formula that I gave you in the beginning. Okay, so you have written down that formula, so we'll use that formula now. Lambda cube minus trace A lambda square plus m11 plus m22 plus m33 lambda minus determinant of A, okay, equals to 0. This is the formula we had written down. Alright, so we go about this now. So the formula, when we are using, the first two terms are very easy to write down, that's not a difficulty, but this m11 is sometimes difficult to children. So now see how to write it and be very careful while writing this. Lambda cube minus the trace. Now what is the trace? 8 minus 3, 1. Can you tell me what is the trace? The trace answer? Let's wait in comment section. If anyone is finding the trace is going to be please write down your answer in comment section. What is the trace? The trace is the total of the diagonal element. So the trace is going to be over here. The trace, I'll help you out. 8 plus 1 is 9, 9 minus 3 is 6. Alright, we got an answer, it is 6, so lambda square. Now we have m11, m22 and m33. Now what is m11, m22, m33? Let us see them carefully. See, m11 is that submatrix that you derive by deleting the first row and the first column. So see this, I delete the first row, first column. If I delete here, I am left out with the smaller submatrix over here. This is the portion I am left out with. It is this matrix I am left out. Okay, this 3 minus 3 minus 4 minus 2 1. Take the determinant of this submatrix. When you take the determinant of this submatrix, what you get, you have to write down. So I urge you to write down the solving also, okay, because it is the first question. So minus 3 minus 4 into minus 2 is plus 8, but it is the determinant, so it will come minus 8 over here. Okay, now m22 is obtained by deleting the second row and the second column. So you delete second row and second column, so you delete this one, you delete second row and second column. What is left out? 8 minus 2, 3 and 1. So write down the determinant here carefully. It is going to be 8 plus 6. That is the thing. Okay, now you delete the third row and third column. So the moment you delete third row, third column, what do you get? You are going to get here this number. So 8 3s are 24. So minus of 24 you will get 8 into minus 3, and there is minus of 8 and 4, so 8 fours are minus 32 here you will get, and minus of minus will make it plus, so here it is plus 32. Alright, a quite kind of big number. Okay, and now you need to add this multiply lambda over here. So lambda is the notation that you will be multiplying. Now you calculate the determinant. Calculate the determinant. The determinant of this is going to be, calculate the determinant and let me know how much does it come. You can calculate the determinant via your calculator, or you can do the manual formula. Let me know how much is the determinant in the comment section. How much is the determinant, guys? Those who are watching, you can let me know. Determinant is going to be how much? Answer is going to be, determinant is 6. Fantastic. So we have got the answer 6 over here, that is equals to 0. Now let us simplify all these terms. How much do we get? Let us simplify this. Lambda cube minus 6 lambda square plus, how much is this? It is minus of 11 plus of 14, yeah, plus 14, and here it is going to be 8, right? And then there is lambda minus 6 equals to 0. Okay. Now let us calculate it further. When we calculate, how much do you get further? Lambda cube minus 6 lambda square. Now see, this calculation can be done quickly in your calculator. I am not using the calculator, I am just relying upon the mental mathematics right now, and I am going slowly to explain you. So slowly we'll get it done. So how much do you get here? It is 14, here is 3, you will get 11. 11 lambda minus 6 is equals to 0. Okay, so you get this as your characteristic equation. So this is the characteristic equation. We'll write down here. Do always write down in exam also, that is the characteristic equation. Now what is the thing? Oh, okay, we have got answer from Riyadh saying that it is lambda is 1, 2 and 3. Alright, so when you calculate here, you get lambda equal to 1, 2 and 3, and we will label them. So we'll label them as lambda 1 equal to 1, lambda 2 equal to 2, and lambda 3 equal to 3. So you get this as the answer. Now we go for finding eigenvector for each of the eigenvalue. So the first thing, for lambda 1 equal to 1, we have the equation a minus lambda 1 I x equals to 0. Therefore a minus I capital X equals to 0. Now what do we do? From the diagonal elements we will subtract 1. Okay, so here you will have 7, then there is minus of 4, and then there is 0, and write all other elements as they are. So minus 8, minus 2, minus 2, 4, 3 and 4. x1, x2, x3, 0, 0, 0. These are the thing. Okay. Now comes a very very important part to be explained. Please pay attention on this part. The first thing is that at this stage comes two methods. One is purely mathematical way of solving, which I am going to avoid because many children find it very difficult to handle that. So I am going to take a shortcut method. Now shortcut method is slightly dicey in nature, okay, because it depends upon the nature of the matrix. If you are conversant with seeing the rows properly, then choice of row is what is very important in the method which we are going to adopt. Now understand this very carefully how to do it, and we will be able to get it through. This method is Kramer's rule method. You have to be very cautious with one thing alone, that is, you must not get all values 0, 0, 0. That's it, because we are finding the eigenvector now. Eigenvector cannot be 0. That's the only thing you should remember in the mind right now. So write down, by Kramer's rule we get, now what do we get? Please be very careful and see this. x1 upon something we have to write equal to minus of x2 upon something equal to x3 upon something. We have to write all these things. Now what we have to write, let us see, and how to write, let us see it in detail. Choose any two rows in your matrix that you see in front of you. This is the reduced one, okay, a minus I. In that matrix we have to choose two rows. So I am going to choose the first two rows. Always have a habit of choosing the first two rows. Suppose you choose first row and the third row, then see to it that you don't get answer zeros over here. These places you must not get all three values are 0. That means there is something is wrong, okay. So see to it that you don't get zeros all the time. So we will choose the first two rows as the rows for writing this. Now how to write the values below x1, x2 and x3? So remember here what you do is this. You, for x1 you delete the first column over here, 7 and 4 you hide it, you hide them, and what you are left out, we are not considering the third row at all. So what are we left? We are left with minus 8, minus 4, minus 2, minus 2. That is what we are left with. So that is below x1. Below minus of x2 you delete second column. What is going to come? 7, 4, minus 2, minus 2. Understood this? Yeah. Kramer's rule में minus x2 क्यों लिया? Please explain. See, Kramer's rule, you take minus x2. This is actually the determinant style. Do you remember how do you take determinant? In the first row you go and then there is this minus x2. ये solving उसके लिए है, ये formula है, आप फिलहाल के लिए ऐसे मान के चले, ये एक pattern है और it is just derived the way it is. Right now we won't go into the derivation and how it is claimed, okay. The justification of that is we take two equations and we solve it further, एंड ये लीनियर इंडिपेंडेंस का कॉन्सेप्ट है, उसके वजह से ये आता है. फिलहाल के लिए हम वो सारे कॉन्सेप्ट साइड में रखेंगे. वी विल टेक इट एज अ फॉर्मूला दैट वेन एवर वी राइट फॉर द कॉम्पोनेंट ऑफ x2 वी विल ऑलवेज पुट अ माइनस साइन. ओके. हाँ, फॉर्मूला है वो बात बराबर, पर वो फॉर्मूला कहाँ से आया, वो डेरिवेशन है उसका. फॉर टाइम बिंग वी विल कीप इट, वी विल रिमेंबर दैट x2 के साथ माइनस साइन आएगा. ओके. नाउ x3 के लिए क्या करना है, यू डिलीट द थर्ड रो, द थर्ड कॉलम, आई मीन टू से -2 को साइड में रख दो, तो क्या बचेगा, यू विल बी लेफ्ट विथ 7 4 -8 -4. This is what you will be left with. Now you solve this further. So when we solve this, we get x1 upon, how much do we get, let us calculate the determinant. x1 के नीचे कितना आ जाता है, here you will get 16, and can you tell the answer. x1 is 16 and here it is -8. Okay, minus of 8, here there is minus x2 divided, here it is -14, and then there is +8. And then here you will get, so x3 over here you will get is -28, and here you will get plus of 32. So x1 over here, this is 8, here this is x2 you will get is minus x2 here, and here you get -6, and here you will get x3 is going to be 4. Okay, now this minus sign gets cancelled, so therefore x1 over 8, x2 over 6, and x3 over 4. Now see, when you get this, you are also requested at this stage that you cancel the common factor. Okay, common factor, I can see 2 is the common factor, so I will cancel out and I'll write x1 as x1 over 4, x2 over 3, and x3 over 2. Okay, this is the thing that we wanted. Now comes another important part over here. Let us go in the next part. What I'll do over here, I'll label this as t. Okay, you are allowed to write this as t. You let it as t because it is a common ratio rather. Now you write this capital X. What do you get, capital X? Capital X is x1, x2, x3. So your capital X, now if you see, what does it become, x1 is equals to 4t, then you have x2 is equals to 3t, and x3 is equals to 2t. This is what you get from this. Now when you go to write your answer, you have 4t, 3t, and 2t. This is the thing, and you take t common as a scalar, so you get 4, 3, and 2. Here you put the value for t equal to 1, then you get capital X1 is equals to 4, 3, 2. Okay, this is your first eigenvector. Actually अगर आप ध्यान से देखें यहाँ पर, तो हमारा आइगन वेक्टर पहले आ गया था. कहाँ पर, ये स्टेप पे 4, 3, 2. जब मैंने t लेबल नहीं किया था, 4, 3, 2 ही आपका आइगन वेक्टर बनने वाला है. पर ये क्या है ना, टेक्निकल मैथमेटिकल अंडरस्टैंडिंग के लिए ये एक टी डाल के ऐसे सॉल्व करते हैं। हाँ, वो टी डालना जरूरी है क्योंकि my answer is 432. Somebody other person can also get some another answer. Okay, think somebody can get -4 -3 -2, ये भी आ सकता है. Why does that happen? It happens because of this t. Okay, there is this variation. Your answer of eigenvector may not be unique. It is actually the multiple of this, scalar multiple होगा. किसी और स्टूडेंट का 8, suppose some other student had written 864, it is not wrong, the answer is not wrong, he is just taking the double of the vector, right? So answer is not wrong, it is only thing is that the answer is going to be magnified a bit, ये बात होगा. So this is the eigenvector over here. Now we go for finding eigenvector for lambda 2 equal to 2. Okay, so for lambda 2 equal to 2, what do we need to do is a minus lambda 2 I and x equals to 0. We do this. Now can you write down the matrix on your own? What you need to do, from the matrix which was given to you, you have to subtract 2. So on subtraction, let us see how to write down. It will give you here 8 minus 2 is 6. From the diagonal entry, subtract 2. So minus 3 minus 2 will give you minus 5. 1 minus 2 will give you minus 1. Okay, and then there is this minus 2 minus 8, 4 and 3 and minus 4. These entries will remain as they are, x1 x2 x3 0 0 0. Okay, yeah, diagonal is minus 2. Where is diagonal minus 2? Diagonal is minus 3. Diagonal total, are you saying? Priya, are you saying the diagonal total? For diagonal we have 8 minus 3 and this. Please check your question. We have 8 minus 3 and 1 in the diagonal. Okay, so let us go ahead. Yeah, diagonal, you from every entry you subtract 2. Yeah, that is what it means. Yeah, from diagonal you cut down 2. That is what it will give you. Now again by Kramer's rule, so by Kramer's rule, what do? We will always remember fixed first two rows. I will tell you there are some special examples in which fixing all these rows and all, it won't work. You have to choose, you need one vision in this, that is linearly independent and all. That concept will come, I will explain you how to handle. So we will need this, but for time being always choose first and second row, no problem. First and second row all the time will work. Some special matrices are there, for them we have to be little bit careful, we have to wisely choose the rows. Basically rule is that only, choose them wisely, but then first second row always works, most of the cases, 99% cases. So 1 x1 minus x2, you write down the determinant here, and x3. Okay, would you like to tell what are the determinants going to be there here? Minus, so you choose the first and second row always, as I am saying, trust me on that, nothing would go wrong. -1, -2, uh, yeah, the first and second row you choose. So what do you get? You get here, you hide the first row, you get -8, -5, -2, -2. Then hide the second row, you get 6, 4, -2, -2. Hide the third row, you will get 6, sorry, column, I mean to say columns. Hide the columns over there, first column, second column, and the third column. So 6, 4, -8, -5. Do that. Can you get the answer? If you are solving, solve and let me know what are the answers coming in the comment section. So x1, below x1, what do we write? And below this, what do we write? I'm waiting for your answers, so let me know in the comment section. So below x1 we will write 16 and plus 16 you have there, and minus of 10, so answer is going to be 6 basically. I have revealed one answer, so just see. Are you people solving on the other end? Comment yes. Yeah, 6 is the answer there. What about this one? Then there is -12 and then -20. -20. Are you sure? -12 and yeah. No, it's not -20. It's not -20. Yeah. Yes. So here it is not -20. It is going to be. No, no, it is not -20. It is. See here it is -12 and 4 into -2 is -8, and there is determinant sign is there, right? So it is +8. Yeah. So 6 into -5 is going to be -30, and then yeah, Akash is saying -4, 2. Yeah. 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 So -30 and here there is plus of 32. Yeah. So it is going to be 2. So you have x1 over 6, and here we have minus of x2 over -4, and here x3 over 2. So final answer is, you reduce it as much as possible. Every time reduce the common factor and write down x1 equals to 6 minus here, then there is x2. Okay, make it positive then. X2 equal to 4, and here x3 is equal to 2. So you have x1 over 3, x2 over 2, and x3 over 1. Okay, you put t then and you will get your answer. So your capital X is x1, x2, x3. You have then 3t, 2t, 1t, take t outside, you will get your answer. 3, 2, 1. Okay, so put t equal to 1, and then you have capital X2 as your eigenvector as 3, 2, 1. Similarly, we calculate lambda 3 equal to, when you have lambda 3, what do you go for? Yeah, fantastic. 3, 2, 1. So we now go for calculating for lambda 3. Lambda 3 is 3. So subtract, you have a minus lambda 3 over capital X equals to 0. So you will have 8 minus 3. When you do 8 minus 3 here on the, so I'm sorry for the disturbances happening behind. I cannot control those sounds here. Like there is a lot of noise from the roadside and the, you know, outside my house. So I'm sorry for the disturbance. Uh, Here, like when you have 3, you will subtract 3 from the diagonal entries. So what do you get is, on subtracting 3 from the diagonal, you'll get 5. Here you'll get minus 6, and 1 minus 3 is minus 2. And then here you have minus 8, minus 2, minus 2. Yeah. And then, thank you for the cooperation. Uh, Now when you have this values over here, you have 4, 3, minus 4, and then x1, x2, x3. So 0, 0, 0. This is what you have, and again choose this first two rows for Kramer's rule. Let us choose the first two rows. Always choose first two rows unless there is all rows are zeros or something, and they won't come like that. It never comes generally, but avoid the elements where there are zeros, otherwise your answer starts boiling down to zero, so then that becomes a little bit problem too. I'll take up some examples in those cases also in the next live lecture. By that time, I will be also comfortable with this live settings and all. It is almost there, but I just have to get little bit, used to it. So now, by Kramer's rule, you write by Kramer's rule. How do we do this? You have here x1 over some numbers will come, minus x2 over some numbers, and then x3 over some numbers. Now what are those? First two rows we have chosen. Hide the first column for x1. So when you hide that, minus 8, minus 6, minus 2, minus 2, then here you have the next one. Here it is, you hide the second column. Second column, when you hide, you get 5, 4, minus 2, minus 2, and then here you get 5, 4, minus 8, minus 6 when you hide the third column. So write down the answers here that you get. So you must get good answers. Oh wow, we got the vectors also. Wow, fabulous. So you have got the vectors as 2, x2 is 1, and x3 is 1. Alright, fantastic. So when you have solved, this is after the reduction. Yeah, 4 2 2. Fine. Okay, so this is after the reduction. The answers here are, okay, 4 2 2, and so on reduction you'll get x1 by 2, x2 by 1, x3 by 1. Alright, so final answer, you can put t here itself and then you write x1 equal to 2t, x2 equal to t, x3 equal to t, and then you go for writing your capital X3. Capital X3, if you want to write, yeah, it's x1, x2, x3 general format. Okay, and then this is the capital X, so here you have 2t t t, and then it is sorry, t outside, and then 2 1 1. So put t equal to 1, capital X3 equal to 2 1 1. Okay, ये 2 1 1 आ गया. Yeah, there is minus. Minus is not there. Priyad, you have made some error, I believe. Just see in this, minus is not there. I think there is some mistake has happened. Oh, I I think, see, my screen is, I think computer is lagging here a bit, so those vectors and all, they are not visible. So let us see what was there. See, the screen is gone. I don't know what happened. Something has happened. Some terms are gone, whatever I had written. Yeah, 211 is the correct answer. Just check the second term what you had got when you had put the sign. Yeah. Let me just handle that. X2, when you write, what do you get is 5 4, and here it is minus 8, and minus 2 minus 2, right? So when you have minus x2 term, when you write, it is 5 4 minus 2 minus 2. So on this part it is minus x2 divided by minus 10, and then there is plus 8, right? So this will give you, below for x2 it will give you minus x2 divided by minus 2, minus minus cancel, so x2 over 2 you will get. You must get 2. Minus 2 is not the thing. Okay, so I hope you got that. Yeah, please check your answers. So the final answer is 2 1 1. That's what you got, right? So 2 1 1, that's the answer. So we got 3 eigenvectors. Now this is the eigenvector for lambda 3. Now let us just write all the 3 together and conclude this question over here, and I'll take up the next part. So what I want here to conclude is that, just conclude this here, lambda 1 is 1, lambda 2 is 2, lambda 3 is 3, and corresponding, see, this word corresponding is very important in mathematics, because it tells you for lambda 1 you have x1, corresponding eigenvectors are x1 is we had got 4 3 2, x2 is 3 2 1, and x3 is 2 1 1. Okay, this is what we got. Yeah, minus and minus gets cancelled. Yes, yes. Yeah, yeah. That minus and minus, yeah, correct, correct. So that minus sign will get cancelled. Yes, yes, correct. You have done correct. You just have to cancel that minus sign. Yeah, correct, correct. Got it, got it, got it. Yes, yes. So I hope you all, Priya and Akash, you are on the same step. So you have got this part over here. Fine. So yeah, minus minus, yeah, you have to be very careful. This is the major mistake that happens in exam also. People forget that minus sign with x2. Yeah. So we get this over here. This is the eigenvector and the eigenvalues we have got. So now what do we understand from this question? Let us understand with the results that we got. That let us also verify the properties. The properties that are 1, 2 and 3 are the eigenvalues. If you take the total, you get the trace. Just check the total. Total is 1 plus 2 plus 3, 6, and 6 was the trace over here, right? Determinant is 6. 1 into 2 into 3, determinant is 6. That is what is we have to verify all the time, because these are the properties of eigenvalue, eigenvector. Now one more thing we learned, that when the eigenvalues are distinct, the matrix is diagonalizable. Here they have not asked, but this is a diagonalizable matrix. Okay, so if you want to find the matrix P, we can do that. Okay, so let us check the matrix is diagonalizable or not. We will just use the result straightforward. If the eigenvalues are distinct, the matrix is diagonalizable. And how it is, what is the diagonal form? PDP inverse. Okay, PDP inverse, when you do, you will get that. So you get that form of the matrix and you get that answer. So let us see that how to handle it. So to make it diagonalizable, matrix P is going to be basically x1, x2, x3. You make a matrix out of this. So this is 4 3 2, 3 2 1 and 2 1 1. Okay, this is the matrix P you will get when you formulate for a model matrix. This is the model matrix for the showing the matrix is a diagonalizable matrix. And what is the P inverse? Now this P inverse you need to calculate. So can you calculate P inverse? Product of, yeah, correct, absolutely correct. So can you calculate what will be the P inverse? P inverse I have already calculated for you people, but I would like you to just calculate for yourself. I'll give you the first row, 1 minus 1, 1 and 1. Okay, so try to calculate the entire matrix P inverse. So we will substitute this, and you just have to check that PDP inverse in your multiplication will give you the matrix A back. It has to give because it is the mathematical formula. So just calculate PDP inverse. So P inverse, once you calculate, let me know. I'll be happy to write down the final part. So are you there online? Just hit yes or just hit a thumbs up, then I can understand. On calculation, you can use your calculators if you have, or otherwise you will need to do the manual way. Manual way is slightly lengthy, taking the transpose, then finding the cofactors and the minors and everything, and getting the whole thing fit at the proper place. Hmm. Yeah, Priya's there. Fine. So anybody else who is there online, you can. Yeah, so have you got the answer? If you have got the answer, just let us quickly write down the answer. From your calculator, you will need to calculate this. So, yeah, second row is 1, 0, minus 2. Correct, absolutely correct. And the third row is 1 minus 2, 1. Yeah, correct. So, this is P and this is P inverse. Let us now write the D. D is basically lambda 1, lambda 2, lambda 3. Now I also want to tell you one very important thing here, that suppose that I'll write here. Suppose you write your D matrix here, and I have given you the formula that it is lambda 1, lambda 2, lambda 3. Okay, so rest all other places there is 0. So we will be having matrix as 1, 2, 3, 0, 0, 0, 0, 0, 0. This is how we will have. And we have got the P matrix. Suppose sometime you got your answer as, instead of this 1 2 3, you wrote your answer as 2 1 3. Okay, you wrote lambda 2 first and then you wrote lambda 1. Then your matrix P will change. Your matrix P will become x2 x1 x3. Okay, so in that case the matrix, if you are writing this, for this the matrix will be 3 2 1, 4 3 2, and 2 1 1. This is how it will change. This is based upon permutations. Okay, yeah, there is an inverse button in Calci. I think in Calci there is a command. Okay, in your calculator there is a command which you can give directly, it will give you. Okay, so are you clear on this concept, that the order in which you write your lambda, the same order you must write the matrix P. So that is how it is. Are you clear with this? Order in which the eigenvectors are written, the same order the diagonal eigenvalues will come. Should not be any change. So now we calculate, we have to show that this is the diagonal form. If you are going to find the diagonal form, what you need to do, I'll just erase this part. So what is expected is now is this, that is PDP inverse. So consider this, we consider this PDP inverse and we calculate the whole thing. Okay, and this output, this is basically, you don't have to do any manual calculation as you are equipped with calculators. So you just put these three matrices in your calculator, you get the answer. Answer has to be capital A. So if you directly, if you work a bit smart way out, then you will know what to do, you know. Here you just plug up your answers, whatever the answers are. So 4 3 2, 3 2 1, and 2 1 1. And here it is, you have 1 2 3 0 0 0 0 and 0. Once you have this, you write down the inverse. So inverse was minus 1 1 1, 1 0 minus 2, and 1 minus 2 1. So this, when you do actual multiplication, you must get your capital A back. Okay, I let's do that quickly. So here this is 4, here this is going to be 6, here this is again 6, here it is 3, here it is 4, then here it is going to be 3, then there is 2, then there is again 2, and then there is 3. Do this multiplication: minus 1 1 1, 1 0 minus 2 1 minus 2 1. If you do this, you must get A back. So minus 4, yeah, you do get, right? 12 minus 4 is 8, and minus 8 minus 2, 4 minus 3 minus 2, 3 minus 4 and 1. This is the output over here. You did not get how to form matrix D. Okay, let me help you. D is the matrix made up of eigenvalues. D is the matrix made from eigenvalues. And remember how we made matrix P? P is made with the formula x1, x2, x3. So D will be made with corresponding, which is the first eigen vector you wrote? You wrote capital X1. So the first eigenvalue in the diagonal will be lambda 1. Second, you have written x2, then you will write lambda 2. Third, you have written x3, then you will write lambda 3 in the diagonal. This is how you have. Yeah, it has to give you the main matrix back. Yes. So this is capital A. So PDP inverse is A. So remember, whenever you have the different eigenvalues, the distinct eigenvalues, when you have this matrix is always diagonalizable. Okay, whenever the eigenvalues are distinct, the matrix is diagonalizable. Another important thing is how to formulate P and D. P matrix is made out of the eigenvector. Eigenvector, you write the way they are, the way you got, and corresponding to that, so if the first eigenvector is x1, then the first value in the diagonal will be lambda 1. If second vector is x2, then your eigenvalue will be lambda 2. If then third vector is x3, then third eigenvalue on the diagonal will be lambda 3. इतना ध्यान रखना है. Now see, if you change the order of P, suppose if I write, suppose some student writes x3, x1, x2, then in diagonal he or she has to write lambda 3, lambda in the diagonal matrix he or she will get lambda 1, lambda 2, like this will be the order. Okay, this is how you will get in diagonal if you write like this way. If you change the order of the eigenvector, then the eigenvalue order will change. Got that? Yes or no? Please let me know whether you followed this part, that if you change the order of the eigenvector in the matrix P, then the diagonal order will change. The order of eigenvalues in the diagonal will change. Do you understand this? This is very important. This is the concept that will take you to a further uh, part. I That is not my task right now. This concept leads you to computers. Yeah, yeah. D equal to lambda values in diagonal, but same. The order is right now the way they are positioned. Their position changes as the way the position changes in the, yeah, yeah. That is not the problem, Priya. Please listen. That problem what I am addressing is that if x3 comes first, yeah, then you have lambda 3 as the first element in the diagonal. This is what is important, because this concept takes you to something called as condition number and permutation of the matrix. This is all there is there, but right now I won't go into that detail because it will take you to another dimension. But this is how it starts. Okay, so this is there. Now we take up another important example here. Let us see the example here, how to handle the next case. Here I am taking the eigenvalues when they are repeated eigenvalues over here. So let us see what will happen. The question, now I am extending this question completely, and this is very very important. Yeah, let us see now. Find the eigenvalues. Oh, or I'll write like this better. First I'll give you the matrix. I'll give you the matrix here. A. Okay. A is -9, -8, -16, 4, 3, 8, 4, 4, 7. This is what we are taking right now. Yeah. Yo. Clear entirely. Yeah, superb. I like that. That great. So we'll write this question now. So what is there here? Let us see. In this part, the question, there are first question I'll take is find eigenvalues and eigenvectors. Now this is a very important question, because in this we are going to have a very special case of repeated eigenvalues. Okay, that's why I'm taking this question now. Let us see what all things can be done here and how to handle. The method is slightly different and very much slightly, rather very much different than the previous part. So let us do this. So this is the first question, and also second one we will like to form find the diagonal form, or they generally don't ask you like this, but they ask you in exam as we will will take that part maybe next time. Let's take that part next time somewhere with another example, because I don't want to deal with extreme complications in this itself, because those are a slightly advanced notions. Let's see later on we can do. We'll do that next part. Yeah. So we'll do this only, finding eigenvalue, eigenvector, because already there is a lot of thing going on and it's a very lengthy question itself. So now let us do how to handle this. Answer. The first step, the standard fixed step. Every question you must write this. Let ax equal to lambda x, x not equal to 0. You must write this. Next, what do we do? What do we do now? We write determinant a minus lambda I equal to 0. After that, we from the matrix we put a determinant sign, and from the matrix we will subtract the lambda. So from the diagonal entry, 9 minus lambda, 3 minus lambda, 7 minus lambda, 4, 4, 4, minus 8, minus 16 and 8 equal to 0. This is what we are supposed to write. Calculate the characteristic equation from this. You can write down the formula lambda cube minus the trace A lambda square plus m11 plus m22 plus m33 lambda minus determinant A equals to 0. Okay. So let us see what all thing we get. Lambda cube minus trace A. What is trace A over here? What is the trace A? Can you tell? Trace A in this is going to be 3 plus 7 is 10 and 1. So 1 is the trace. So lambda square. M11. Can you calculate what is M11? M11 is obtained by deleting the first row and the first column. So you will get here, yeah, add of diagonal, yes, add of diagonal is 1, but it is, see, appended, you have to remember there is minus sign. Remember, sometimes trace comes negative, then be very careful with that. Minus minus will make it plus, but here it is positive 1. Okay, so what is M11? M11, you delete the first row, first column. So delete first row, first column. What do you get? 7 3s are 21, 21 minus 32. How much is that? Yeah, minus 11. Next, what is the next number? M22. M22 is obtained by deleting second row, second column. Delete second row, second column. Determinant is 3. M22 is 1. Wow, fantastic. M33, determinant is 3. Thank you. What is M33 is 5. Okay. So I hope you got that. That is done by deleting the third row and the third column. Okay. So I'll erase this here and this here also. And determinant determinant is 3, right? Just check on your Kelsey that you get determinant equal to 3. Okay. So on simplification, lambda cube minus lambda square is equals to minus 5 lambda, right? 6. Yeah. So we are getting here the answer as 6 minus 11 plus 5, yeah, minus 6, minus 5 lambda and minus 3 equals to 0. How much is the, what are the values that you get? Have you calculated? Have you calculated the values? Determinant is 3, correct. Can you calculate how much is the eigenvalue for this equation? What are the values are you going to get? So also write here, do write that is the characteristic equation. This is a characteristic equation. What are the eigenvalues? Is anybody solving? Please let me know. What do you get? Calculator will give you the answer over here. Yeah. No, you must get minus 1 as the answer. Something is wrong. Minus 1, it has to be the repeated case. Just check. In your calculator, you must be getting a different answer or what? Just check. Do you get lambda equals to lambda equal to 3 minus 1 and minus 1? You must get minus 1. Yeah. Listen carefully. In calculator, when you don't get the third value, so the second value which you got in the calculator, that is the value which is repeated. Yeah, now comes mathematics here, but this is all rules of mathematics. The rules of mathematics are that if you have a third order, a polynomial of degree 3, okay, polynomial of degree 3 is there, you must get 3 roots. Here complex numbers are allowed, but in our exam we may not get complex number. 99% we don't get complex numbers, but you can get also, okay, not a big issue. Right now here we have, in our case, 3 answers are going to come. So the third answer in your calculator, the second value is shown minus 1. So third answer is minus 1. Okay, second value, the last value which comes, if you do not get the third answer, that the last value is repeating. This is the meaning in the calculator. So minus 1 is flashed 2 times, so you won't be able to see the change, right? So minus 1 is being flashed 2 times, so that is why minus 1 is there. Got that? So the logic here is minus 1 is repeated 2 times. Got it? Am I clear on this? Or do you need any explanation for this? Okay, let us go further. Otherwise, -1 आपके कैलसी में 2 बार आएगा, मतलब वो 2 बार फ्लैश हो नहीं रहा है ना, क्योंकि -1 ही आंसर है. Okay, so here you have lambda 1 equal to 3 and lambda 2 equal to -1. Okay, now comes very important thing. Oh, thank you. Now comes very important thing here. There is a concept of algebraic and geometric multiplicity which I will deal next class with this similar example. Now comes very important thing, how to find eigen vector. See, 3 is not repeated, right? So no problem, and it is different from -1. Okay, so we will use Kramer's rule for finding eigenvector for 3. ओके, सो सिंपल है, उसके लिए क्रेमर रूल यूज करेंगे, उधर कोई प्रॉब्लम नहीं आएगा. लैम्डा 1 को आइगन वेक्टर जो ढूंढना है क्रेमर रूल से आ जाएगा. फॉर लैम्डा 1 इक्वल टू 3 वी विल बी यूजिंग a minus lambda 1 I on capital X equals to 0. So you have a minus 3I capital X equals to 0. So formulate the matrix, you get -12 4 4, right? Subtract 3 from the diagonal entry, so 0 and then 7, here you get 4, here also you get 4, -8, and then there is -16, and here it is 8, and then there is this x1 x2 x3 equal to 0. You get that? Okay, this is what you have got. Calculate by Kramer's rule. What do you get? Now let us see. Here you will have x1 minus x2 x3, and then there is this. Okay, so when you hide the first column you get 4 0 4 4. When you hide the second column you get -12 -8, and then you get 4 4. Use the first two rows to calculate the answer. And when you do the for the third one, what do you get is -12 -8 and 4 0, right? So you are hiding the third column. Okay, so on calculation x1 is 16, here minus x2, how much does that give you? -48 and 32. -48 plus 32. x3 when you have is, this is gone 0, so there's 32 again. Yeah, so x1 over 16 minus x2, this is going to be minus of 16, and x3 is 32. Okay, so x1 we will reduce the common factor, so and minus sign gets cancelled. So here you have 1, x2 is 1, and x3 is 2. So my eigenvector is basically x1 x2 x3. I can now write this as, if I put t over here, then it is t, t, 2t, t taken outside, it is 1, 1, 2. Yeah. So my eigenvector is basically x1 equal to 1, 1, 2. ये हमारा आइगन वेक्टर हो गया है. सब लोग को आ गया समझ में? हाँ, इसमें कोई प्रॉब्लम नहीं है, ये पहले जैसा ही है. अभी प्रॉब्लम इधर आने वाला है जहां पर रिपीटेड आइगन वैल्यू है. हमारा आइगन वैल्यू आया था -1. यहाँ से दिक्कत शुरू होती है. द प्रॉब्लम स्टार्ट्स हियर. लेट अस राइट दिस केयरफुली and please make a note. I'll write this with what, yellow color, or let's write with blue color, something very important, very important note. Please write down this thing, you will need this all throughout, that whenever an eigenvalue is repeated, do not use Kramer's rule. Do not use Kramer's rule to find eigenvector. This is very important. We have another method for that. Now that method is slightly different. Now there is no way out. You have to do this. Let us see how to do. So let us see. For eigenvalue for lambda 2 equal to -1, we will have a minus lambda 2I x equal to 0. What does this mean basically? Basically it is a plus I capital X equal to 0. So a plus I, when you do in the matrix, diagonal entries are added with 1. So you add your diagonal entries to 1, right? So -8, 4, 4. Then there is -8, 4, 4. Correct? Then there is -16, 8 and 7. अभी देखो, अब मैं आपको बता देता हूँ कि क्रेमर्स रूल क्यों यूज नहीं करना है और क्या हो जाएगा क्रेमर्स रूल यूज करने पे. मैंने आपको क्या बताया था कि हमारा क्रेमर्स रूल से आंसर गलत आएगा. क्रेमर्स रूल नहीं करना है इसमें. देखो, अगर आप क्रेमर्स रूल करते हैं तो क्या होता था. देखो, फर्स्ट 2 रोज चूज करनी है, बराबर. अगर हम करते तो क्या करते, x1 के नीचे फर्स्ट 2 रोज लेते, 4, 4, 4. तो ये 4, 4, 4 आता है इधर. x2 के नीचे -8, 4, 4. फिर x3 के नीचे क्या आता, सेम -8, 4, 4. ये आता. हर जगह पे x1 के नीचे 0, -x2 के नीचे भी 0, x3 के नीचे भी 0. हो गया, खत्म. हमने क्या बोला था कि हमारा आंसर आइगन वेक्टर का 0 नहीं आ सकता. अब 0 आ गया. अब क्या करेंगे. हाँ, एक मिनट. हाँ, यहाँ पर 8 आएगा. इधर 8 है. इरेज करके यहाँ पे 8 है ना. डायगोनल में हम 1 ऐड किए तो 7 का 8 हो जाएगा. तो ऐसे क्वेश्चन में क्या करें जिससे हमारा आइगन वेक्टर जीरो ना आए। तो अभी यहाँ से स्टार्ट होता है गेम। करे चालू, देखिए क्या होगा। तो पहले मैं इरेज कर देता हूँ ये सब, तो आपको पता चलेगा। अभी ये करना नहीं है ऐसा, ये माइनस जीरो जीरो अगर आ गया तो समझ जाने का कि कुछ गलत हो रहा है। ये जीरो जीरो नहीं आना चाहिए। तो देखो क्या करना है। सबसे पहले यहाँ पे दिखाई दे रहा है ना कि -844 ये सब सेम है। हम पूरे क्या कर देंगे, अब पूरी रो को डिवाइड कर देंगे वो कॉमन फैक्टर से। क्या हो गया, R2, R2 नहीं R1, R1 को ये कर दो। एक मिनट। हाँ, अच्छा, हम लोग है ना रो इचेलॉन फॉर्म लगाना है। एक्चुअली बेसिकली करते क्या है यहाँ पर, जब ऐसा केस होगा तो रो इचेलॉन फॉर्म बनाना है। whenever eigenvalues are repeated, you have to solve the system of equation properly using row echelon form. Okay, so what do you see here, that second row is exactly same as the first row, and the third row, can you see, is exactly double of the first row. तो R2 माइनस R1 कर देंगे, एंड R3, हाँ हाँ, थैंक यू थैंक यू, R3 changing to R3 -2R1 ये कर दो। तो क्या होगा देखो, -844, ये वाला रो 0 0 बन जाएगा, इसके नीचे भी 0 0 आ जाएगा, x1 x2 x3 ये बन गया। और अब 0 0 0 ये यहाँ पर ऐसे बन गया, बराबर। अब कैसे करेंगे, ये सब 0 0 बन गए हैं और क्या करना है कुछ समझ नहीं आएगा, तो क्या करेंगे देखो। तो अब हम क्या करते हैं, और इसको रिड्यूस भी करा जा सकता है, कर लो चलो। R1 को 4 से डिवाइड कर देते, R1 डिवाइडेड बाय 4 कर देते, तो क्या मिलेगा मुझे, -2 1 1 0 0 0 0 0 0. This is what you will get. You divide the first row by 4. Okay, so 1 x1 x2 x3. Okay, yeah, thank you Akash 78, but yeah, I got that. Yeah, now we will go further. How to handle this case? This case, here starts the whole thing. You have to understand what is the rank. First write down rank of a minus, or a minus lambda 2I. What is this a minus 2I? Rank of a minus 2I is same as the rank of a lambda 2 कितना था, -1, मतलब a plus I का रैंक। a plus I का रैंक कितना मिला, दिस इज द मैट्रिक्स। तो रैंक इज द नंबर ऑफ नॉन जीरो रोज। तो कितनी रो है जो जिसमें नॉन जीरो है, पूरी की पूरी रो, ये -2 1 1, एक ही रो है। तो रैंक ऑफ a plus 1 is 1. How many unknowns are there? Number of unknowns, number of unknowns knowns equal to n. This n is how many, there are 3. Okay, and this rank, if I label this rank as R, then I have something called as number of free variable. Free variable is n minus R. n minus r will become 3 minus 1, which is 2. So two variables are going to be free. This is the most important concept you must understand, and let me know if you have found any difficulty in these three lines. Is there any difficulty? Please let me know. Because all this thing was taught to you in your previous semesters, you need to bring them back. Any doubt you have or any difficulty, just comment in the comment section, or then otherwise we will move ahead. Okay, no difficulties, fine. So now see, number of free variables are 2. Okay, number of free variables are 2. So now see, when I simplify this equation here, this matrix equation which you see, what do I get? I will get minus 2x1 plus x2 plus x3 equal to 0. Okay, this is what I will get. Now it becomes my choice what two variables I want to make free. Which two variables you want to make free, you tell me. You can choose any two variables of your choice and you can set them free. हाँ, थोड़ा लेट होता है ना, वो लेट कमेंट आ रहे हैं. नो प्रॉब्लम, नो प्रॉब्लम. हाँ, हो सकता है ना, नेटवर्क अभी अपना छोटा सा सेटअप है, छोटे से सेटअप में अपन काम चला रहे हैं. आप अभी ये इक्वेशन लिखिए and tell me which two variables you want to set free. Two variables, you can choose your choice. Whichever two you choose, you will get the answer accordingly. So comment there which two variable you want to choose free. x1 x2 x2, x1 x2, chalo. So we will choose x1 and x2 free, right? So everything should, so you can write keep those variable on RHS. जिस वेरिएबल्स को आपको फ्री करना है, आप उनको RHS में डाल दो. अच्छा, x2 x3 को फ्री करना है. ओके, x2 x3 को कर दे. चलो, तो जो भी वेरिएबल को फ्री करना है उनको RHS में भेज दो. तो क्या हो जाएगा? -2x1 इक्वल टू -x2 -x3. ठीक है. हाँ, तो x1 क्या हो जाएगा? फाइनली x1 अकेला कर दो, मेक इट अलोन. सो यू विल हैव -x2 -x3 डिवाइडेड बाय 2. बराबर? ओके. नाउ I will write in the next part over here. See this, how to write this. You have your matrix X in the general formula as x1 x2 x3 here. Okay, so x2, how is x2 written? You have said x2 and x3 are free. What is x1 we wrote? We have written x1 as minus x2 minus x3 divided by 2. x2 is written free. You have told we don't want to put any restriction on it. So x2 is free. x3 is also free. We are having freedom of our choice. We choose it. minus 2 minus 2 ah minus 2, yes, 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 correct, 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 minus 2. So yes, so this will become x2 plus x3 upon 2. Yeah, correct. So then this will be plus. Thank you, thank you, thank you so much. Okay, minus 2, and so yeah, got it, thank you, thank you. So x2 plus x3 upon 2 you got, and this is what you substitute in the general formula. Alright, bang on. Okay, now let us go further. What we will do now, there is this matrix addition ka concept you have. What is this concept? Is this, I can write x2 upon 2 plus x3 upon 2. This x2 that you see, I can write x2 plus 0x3, and the x3 that you see can be written as 0x2 plus x3. Correct? Now this can be split like this: x2 upon 2, x2 and 0x2 plus x3 upon 2, 0x3 and x3. Are you getting that? This is very crucial. Once you are comfortable with this understanding, you will be able to follow. From this one, this expression, you take x2 common. Take x2 common, so you get half 0. Oh no, sorry, you get half 1 and 0, and the next one here you get, take x3 common, you will get half 0 and 1. Are you getting this? Let me know once you reach till this step. Okay. Have you followed till this step? Then we go ahead. So have you followed? Just hit yes or a thumbs up, then we can go ahead. Okay, so now comes, these two vectors are your eigenvectors. These two vectors that you see, half 1 0, half 0 1, these are your eigenvector. Okay, just a minute, from where do you wish to see back? I'll explain. See, when you substitute, you get the relation, over here, x1 equals to x2 plus x3 upon 2. That is the relation you got. Am I clear? Like, I think Priya has a network issue, so can you are you comfortable till this step? And then we go over here, you substitute that relation, whatever you got, you substitute that relation in the general vector formula. In the general vector formula, what you need to do is you write split x variable, x2 variable and split x3 variable. So I have split this way, x2 upon 2 and x3 upon 3. This is how the split has happened. X3 upon 2, that split. Then x2 can be written as x2 plus 0 x3 and x3 can be written as 0 x2 plus x3, right? Then you treat this as matrix addition. When you treat this as matrix addition, two matrix will be separated. Then x2 you take common from the first one and take x3 common from the second one. Got it? So you have your eigenvector ready in front of you, that is you have your x2 vector as half 0 1 and x3 vector as half 0, no sorry, you have your vector here will be x2 vector will be 1 0 and this is 0 1, half 0 1. This is the vector. Okay, now listen carefully. This half as a fraction, we generally don't put fractions in between. So what we some student can also say, sir, my vector r x2 is, you double this, half is there now, you double the vector, put x2 equal to 2, so you will get 2, here you will get double the vector, so what you will get is 1 2 0 this, and in x3 also you put x3 equal to 2, so x3 you will get 1 0 2. This is also correct. These are the two eigenvectors for the given question. Okay, now see, we had got eigenvalue -1 repeated 2 times, right? -1 was repeated 2 times, so we got two different eigenvectors. Are you getting that? -1 was repeated 2 times, we got two different eigenvectors. These eigenvectors that we got here are the final answer. You can either, this is optional, this is optional, or alternative answer. This is also right. The below answer which I gave, that is also right, because that is half, you are just doubling the vector. I told you that eigenvectors are not unique, they can change from person to person. Are you getting that? Okay, hit like in the like section or in the comment section, then I can follow that. So this is how you find the eigenvector for the repeated case. So if you want to try any question on repeated case, I'll give you that, and so that you know you have a hold upon the topic. You can try this question. It's a good question. You can try this. Try yourself. Here for A, try to find the eigenvalues 2 minus 1 1 minus 1, 2, minus 1, and 1, minus 1, 2. This is also a good matrix, and you will get repeated eigen values in this case. Okay, so you will get the answer over here. So I'll tell you the eigenvalues that you will get is this. The eigenvalues that you are going to get for this, you will get eigenvalues as 4, 1, 1. Okay, so let me know the eigenvectors in the next video live when I go, and yeah, I'll be going live soon, possibly uh, maybe Tuesday or Wednesday or maybe next Saturday. Let's see. So this is the uh, eigenvalue and eigenvector concept, how to find eigenvalue when they are distinct and how to find eigenvalue when they are repeated. Now comes a very important part. Let me just add few slides here. Okay, now comes the next part here, that is how to find the thank you so much. um, how to find the Cayley Hamilton theorem statement and everything will come. Now this is a very simple and a very easy concept. Okay, there is nothing much to this. It is just annihilation, but we need to know because later on the concepts are there. So I'll just give you the statement, very simple and very nice things are there. We'll do a very small example related to it, and then we can hold upon it. Similar matrices, also I have given you a small picture about it, but then we will see them in detail in the next live. I'll do this question on Cayley Hamilton for you people, and then we can stop because we are already running a long time duration on this. So we will stop after this and then we can see. So Cayley Hamilton theorem, this is another very famous theorem in mathematics, and the proof is very lengthy. Uh, so we will avoid proof, we will just take the statement and we will use it. So statement is this: every square matrix satisfies its characteristic equation. That's it. This is all. And now see, just few simple words but heavy technical mathematics. Okay, so this is the statement. There is nothing much looking nice about it, but then you have the statement here. So let us see what all kind of questions are asked on this, and then we will do the thing. Let us take up this question. I had already done this for you guys, and so that would be very easy for you. So the question here, yeah. So the question here is this: for A equal to, we have already seen this matrix 1 2 4 3. Okay, we do this. Use Cayley Hamilton theorem, use Cayley Hamilton theorem and find A inverse. Find A inverse. Now this is, see, I feel this is very redundant because it is outdated. Now you have heavy calculators available who can give you A inverses at just click of a button. You need not have this technique, but this technique is very powerful when you have the following question. And also find a linear polynomial or linear expression of a raised to 5 minus 4a raised to 4 minus 7a cube plus 11a square minus a minus 10I in terms of a. This is how they ask, in terms of a. Now let's see how to do this. This is very easy. So whenever this kind of things are given to you, you have this a equal to 1 2 4 3, right? You write down that let ax equal to lambda x, x not equal to 0. You don't have to find the eigenvector in this, okay? Remember, you don't find eigenvectors. Let ax equals to lambda x, x equals to 0. This is just a formality over here. So you do determinant a minus lambda I equal to 0. You have to find the characteristic equation. Okay, you find the characteristic equation. So here the thing is lambda square minus the trace, that is 4 lambda, plus the determinant. What is the determinant? It is going to be minus 5, right? Minus 5 is the determinant here. So answer is minus 5 equal to 0. Okay, this is the characteristic equation, is the characteristic equation. Now you write by Cayley Hamilton theorem, what do you get here? You will get, what is the characteristic equation? Lambda square minus 4 lambda minus 5. You, wherever you see lambda, you replace it by capital A. A square minus 4a minus 5. Now see, 5 is a number, but if you are writing it in terms of matrix, then you will have to write that number is always multiplied by I. Okay, the identity matrix, and that becomes equal to 0. Now it, in terms of matrix, this will become 0 matrix. So by Cayley Hamilton theorem we have this. This is what is meaning that every square matrix satisfies its characteristic equation. This is the meaning. That means wherever you see the characteristic equation, that lambda can be replaced by the matrix. If you write that, then you have this expression which is in terms of matrix. Okay, now this is a very important thing. Why do you need this matrix? Because these matrices are useful in what you call differential equation. That's why this characteristic equation and all that comes into the picture. Okay, so all this polynomial and all, it is there in differential equation theory. That is, you need Fourier and etc etc. When the solutions you start using in bundles, you need all this concept. That is why Cayley Hamilton theorem. So a square minus 4a minus 5i equals to 0. This is what you got. You remember this now carefully. We will call this equation number 1. Now I will take you to the next step. How to find A inverse. Let us see how to find A inverse. This is very easy. In school level or in the high school, 11th, 12th, wherever you were able to do this multiplication, right? So you multiply A inverse throughout. So A inverse into A square minus 4A inverse into A minus 5A inverse I equals to 0, right? So what does this give you? A inverse, okay, this is 4i and this is minus 5a inverse is equals to 0, because we are finding A inverse. So this is what you get. Now A minus 4i is equals to 5a inverse. This is what you get, and hence you have this. A inverse is nothing but 1 upon 5 A minus 4i. Getting this? This is the A inverse. Now you can substitute and get that answer for A inverse. So A inverse, you will be getting that there. Okay, so A minus 4i, you will get the answer there, and that's how it is done. Are you comfortable till this part? Yeah, can you just comment there in the comment section that you are getting this, or otherwise it would get flaw. Yeah, fine. So followed this A inverse procedure, that this is how you calculate A inverse using Cayley Hamilton theorem. Now see, calculators and everything is available, people don't use A inverse, but now when you have big polynomials like this, then you need these kind of techniques. Okay, right now you can just give consolidate ourselves with this kind of understanding, that right now, like, when you have advanced questions, you will be able to handle with this technique. Otherwise we always think of A inverse finding as adjoint over determinant and all, but now this is also easy way out, right? That if you don't know A inverse, but if you know this technique, then you can get the A inverse this method. Okay, so this is how you get the answer for A inverse. Now let us go for finding this polynomial. How to handle? So we consider this A raised to 5 minus 4A raised to 4 minus 7A cube plus 10, no, not plus 10, plus 11, right? Plus 11 A square minus A minus 10I. Consider this. Now they are asking us to find the value in terms of a as a linear polynomial, or sometimes they also ask find the value of this. Now this is a something really nasty thing, that a raised to 5 and like this, how much you will keep calculating all the time. And if you have a calculator it is good, but if you don't have a calculator, and sometimes calculator will also say it is not possible, it is taking too much time to calculate and something like that, and right now it is a small power, then still fine, but still it is a very difficult task to calculate this kind of thing. So what do? You use Cayley-Hamilton theorem. Now how do we do? In school level we have learned the technique of polynomial division, right? So we will do that polynomial division over here. So we consider this division now, that you do this division here. A raised to 5 you put it inside, 4a raised to 4 minus 7a cube plus 11a square minus a minus 10I, and you divide this by the polynomial or the characteristic polynomial. See, whenever you have this equal, if you say equal, then it is characteristic equation, but if you only consider this lambda square minus 4 lambda minus 5, then it is called characteristic polynomial. Equal to 0 लगाया तो characteristic equation बोलने का, अगर equal to 0 नहीं लगाया तो वो जो LHS में लिखा है ना, that is called characteristic polynomial. ये सब technical terms है, ज़्यादा इतना you don't have to get hyper by that, but yeah, when you read you will come to know all these terms are very important. But right now for time being, lambda square minus 4 lambda minus 5, so you use this here, so you can a square minus 4a minus 5I, you do perform the division. When you perform the division you will get a cube a raised to 5 minus 4a raised to 4 minus 5a cube. This is what you get. Then you change the sign, minus plus है तो minus, minus है तो plus and plus. Okay, so on cancellation you these terms get cancelled, you get here, so these are cancelled. Okay, they get cancelled. What remains is minus 2a cube plus 11a square minus a minus 10I. Sorry. Now you have minus 2a. So minus 2a cube, then you have plus 8a square, and then there is minus 10a. So this is plus minus plus. Are you getting this? Are you comfortable? This school level, all revision of all the previous terms that you have done is coming to you. So let me know if you are comfortable till this part, then we can go ahead. Akash and Priya, are you there? Yeah, they are there, I guess. Yeah, yeah. Ved is also there. Wow, welcome. And so yes, so let us go ahead and complete this. And so this, when you cancel, it goes off, and here 11a square minus this, you get here your answer will be 3a square, and then here it is plus 9a minus 10. I. You divide again, so you get plus 3i. Now see, when you divide 3a square by a square, you will say, sir, we get a by a square. When you divide, you will get 3. No, it is 3i. It is a matrix, so you should get a matrix as an answer. Okay, we are not doing under strong notions, but then remember, it is not 3, it is 3i. So here you will get 3a square. Okay, and then there is, how much is this, 3, and then there is minus of 12a, and 3 into minus 5, that gives you a minus of 15i, minus plus, and there is plus. Okay, so finally how much do we get here? It is 9 and 12, that gives you 7, no, 9, 12, 21 a, and then there is plus 5i. Okay, we get this. This is what we get. Okay, now we go further. Final thing, now we cannot do the division further because the remainder degree, the degree of the remainder is less than the degree of the divisor. Now we use a concept which was again taught in the school. See, school concepts are so important. That's why we should pay attention in school also. Dividend is equal to divisor times quotient plus remainder. This is the concept that we have learned. So dividend is this big term that we have written already, right? So that is a raised to 5 minus 4a raised to 4 minus 7a cube plus 11a square minus a minus 10i. This is equal to divisor. Divisor is the the a square minus 4a minus 5i. Quotient is, the quotient is a cube minus 2a plus 3i, and remainder is 21a plus 5i. Okay, this is the thing that we have got. Now how do we go about this next? So the next thing is here is this. What do we know about the characteristic polynomial? That it is equal to 0. We have written in this by Cayley Hamilton theorem, the value is O, right? So here you get O into a cube minus 2a plus 3i plus 21a plus 5i. Okay, so this means 0 multiplied by this big matrix, the value is 0. So 0 plus 21a plus 5i. So now we substitute the value of now this is the basically the linear expression. Do you remember? This is what they had told. They the question that I had given, find a linear expression for this. So this is the linear expression, 21a plus 5i. This is how you do. There is one more method, but I feel that method is very tricky. You may lose terms inside that. When you do this division, you will always get the correct value. Otherwise, it makes a big problem by expansion and taking terms common and everything. It is very confusing for many students, so we avoid that method. We will do this division wala method. So what is here, it is 21a plus 5i. Now uh, this is the answer that you wanted. Sometimes they say what is the value of this expression. How to give the value? You first do all this process, and finally the value of this expression will be, you substitute that. If they are asking the value, you substitute 21 into a, whatever is the value of the matrix A over here, you substitute. So and the value of this big expression, if I call this expression P of A, polynomial of A, equal to, what will be the value? 21, what is that, 1243 plus 5i. So 5i is 5500. You have this, right? So you do this addition. 21 plus 5 is 26. 21 into 4 is 42. Here it is 40. 21 into 4 is no, sorry, 84. Sorry, 84. Here it is 84. 84, and here it is 42, and here this will be 21 into 3 is 63 plus 5, so this is 68. This is the final answer. Oh, let me write this answer somewhere else because it is hiding behind the screen. I'll just reduce the size of the camera here. Okay, this will give you the thing. Yeah. Okay, so I hope you have got this. This is how you find the value of this, and I hope there was no difficulty. If you have any problem or queries, let me know here. Um, and finally we are at the end of the our session, my first live. I know I there was a problem a bit in the initial beginning and maybe now also, but I hope this was helpful. Divide by 2. Why divide by 2? Why divided by 2? I did not get. Divide by 2. What are you saying, Akash? Can you let me know which step do you want? Divide by 2. I don't get. What is divide by 2? Okay, could you please clarify what is the thing that you are asking? Hello? Uh, could you brief anything about it? I'll wait for a few moments so that you can uh, have, if you have any difficulty or any doubts, then you can ask me here. Otherwise we are done for the today's session on my first live. How is there divide by? No, it is not divide by 2. Where is divide by 2? There is no division. There is Where is divide by 2? It is not divide. 21 it is. 21a. So we have substituted there. It is not divide. Oh, thank you so much for your comments. Um, the final answer, Akash, there is no division. There is no division. Could you could you show me what a division you are trying to say? There is no division there. Where is the division? I don't find any division. Alright, I think so that can be settled down later. But this is the final part of the thing that I wanted to discuss with you people. And this is Cayley Hamilton theorem. Yeah, I believe this is all. Plus 10 and 5. Yeah, I think there is a plus 9, 9 and just a minute. 2, 8 and 10 plus 10. Yeah, there is small error. I would like to rectify this. See here, minus 5 when you did here. See, this is minus 5, right? Minus 2a into minus 10. This you do, you will get plus 10. So because of that plus 10, yeah. So this will be minus here. So there is this change. Let's do this change. Minus 10 minus minus will make it plus, so this will be minus, so this will give you minus 11. So yeah, this will give you minus 11. That could be your doubt. Yeah, so this is minus 11. 11, and then this is, erase this, and so this will become a plus 5. So you will have this here as a here. Okay, this won't be 21, then this is a plus 5. A plus 5i is very easy. Then it won't be this big number, it will be just 5 added. So that will be 6, 4 and 2, 8. This would be the answer. Okay, got that? I hope you got that. All of you are there, those who were right from the beginning. I made the little correction in this, so please do this correction, and I hope you got that. Please do try it on your own also, because in on this whole platform I am also just getting familiar, otherwise it's not that difficult. But yeah, fine. I hope you enjoyed it, and it was a good thing. I also realized how whole live thing works, and yeah, thank you for joining in. We shall stop now. Thank you so much. Thank you, and great lecture. Thank you, thank you, thank you, thank you all. Those of you have joined in, and I hope all of you will benefit. This whole thing will be there in the stream section of my YT channel. You can watch that, and yeah, do practice more. We will meet in the next live. I'll take up a different question, and we will be more, uh, you know, at a faster speed. I'll do this. Okay. faster speed, not of internet, of solving. I was very slow now, but of solving we will do it faster speed, so that I just getting adjusted with the whole thing. Okay, so see you then. Take care. Bye bye.